Hi friends, now I'm going to discuss how to find out the eigen values and the eigenvectors. This problem is given in April-May 2008 Anna University exam paper. Here the question is find the eigenvalue of the matrix A and hence find the eigenvalues of A inverse. So to find out the eigenvalue of matrix A, first we need to find out the characteristic equation and we need to solve the characteristic equation for the roots. So those roots are the eigenvalues of the given matrix. Let's write down characteristic equation for 3 by 3 matrix is characteristic equation is lambda cube s1 lambda square plus s2 lambda minus s3 is equals to 0. I told you all these S1, S2, S3 in previous videos. S1 is the sum of the diagonal elements of the matrix. That is 1 plus 2 plus 3 is equals to 6. And S2 is equals to sum of the minor of the diagonal elements. That is determinant of first diagonal element is 1 and you remove first row and first column and rest of the elements we need to consider. That is determinant of 2, 5, 0, 3 and next element minor is 1, 4, 0, 3 and next element, last element is 3. So we need to remove this row and column and you have to consider only 1, 3, 0, 2 and take determinant. So simplifying we'll get 11. S3 is the determinant of matrix 1, 3, 4, 0, 2, 5, 0, 0, 3. So S3 by solving we'll get 6. So just substitute all these S1, S2, S3 and we'll get characteristic equation lambda cube minus 6 lambda square plus 11 lambda minus 6 is equals to 0. Now we need to find out the roots for this characteristic equation. You can use your calculator or this method which I am going to tell now. We have 3 roots because this is lambda cube, so we'll get 3 roots. So first one is, this is the method we need to find out the roots. First, just for any equation, cubic equation, first you consider lambda is equals to 1 and substitute it, check whether it gives you 0 or not. Plus 11. So this is 12 minus 12, that is 0. So lambda 1 is giving you lambda 1 is satisfying the equation and giving 0. So we can consider this lambda is equals to 1 as the one of the roots of this characteristic equation. And after this we need to use synthetic method to find out the other roots. For this method we have to consider the coefficients of the lambda, that is 1 minus 6, 11 minus 6. For this method we need to take the first root 1 here and for the first term we need to put 0 and just add this 2. 1 plus 0 is 1. So again 1 into 1 gives you 1 1 is 1. So again add you these two terms. Minus 6 plus 1 is 5. And now 1 into 5 is 5. This is minus 5. And 11 minus 6 is 6. Just add them up. That is 11 minus 5 is 6. And 6 ones are 6. And add these two. Minus 6 plus 6 gives you 0. Now we can cancel this term. And now we can write, so this is lambda square minus 5 lambda plus 6 is equals to 0. This method is called synthetic method. For this, we need to use the first root and rest of the equation will be like this. So you can write this as, I am splitting this into two terms. You can write lambda minus 3 into lambda minus 2 is equals to 0, and the roots are lambda is equals to 2 comma 3. Roots are lambda is equals to 1, 2, 3. So these are the eigenvalues. And also you observe that this is the right angle triangle. That means in the lower triangle you have 0 values. So for this kind of matrix, we can see the diagonal elements 1, 2, 3. These are nothing but the eigenvalues which we got now. 1, 2, 3. So we can confirm these eigenvalues are correct. Find the eigenvalues of A inverse. For this we have a property of matrices, that is, if lambda is the eigenvalue of A, then 1 by lambda will be the eigenvalue of A inverse. Depending on this property, we can say that the eigenvalue of A inverse are 1, 1 by 2 and 1 by 3.